Welcome to the second half of Lecture 3. In the first half of Lecture 3, we discussed the supply curve, demand curve. We talked about how the demand curve is a reflection of willingness to pay by consumers at different units of that product. And then the producer, its willingness to produce at different prices for that product. On this slide, we're going to introduce a few new concepts. One is called consumer surplus, and basically this is the benefit to consumer above and beyond the price they have to pay. A second one is producer surplus, and this is a benefit to the producer of the price they receive relative to the price they were willing to accept for that product. And then the total welfare surplus is the two of producer and consumer plus surplus combined. So think of it this way. Let's think of the consumers first. If you go to the grocery store expecting to pay $5 for a 6-pack of Coke, and that would be your willingness to pay for the Coke, and you get there and it's only $3, you would have a benefit above and beyond what you actually had to pay. And this benefit would be your consumer surplus. You're happy, and you can think about consumer surplus as being a level of happiness for the consumer. So let's give an example of the consumer, and then we'll also work through the producer surplus. So at one unit, say a consumer was willing to pay $10 for this product. But in reality, so they were willing to pay $10, but in reality they only had to pay $6. So for that first unit, they were willing to pay $10. They actually had to pay the equilibrium price of $6. So they have a consumer surplus of $4. So they're happy with this because they were willing to pay more, but only had to pay $6. That leads to a consumer surplus. For the producer at the same unit of 1, they were willing to accept $2 for that, but they actually get the equilibrium price in the market of $6. So the producer surplus is at $6 minus $2, which is $4 for the producer for that first unit. And if we want to think about what the total consumer surplus is, we continue down this path, and we think for the second unit, the consumer would have been willing to pay $9, but they only have to pay $6, so there would be an additional $3 worth of consumer surplus. We could do the same thing with the producer. They were willing to accept $3, but they get $6, so they get an additional $3 of producer surplus. And we can calculate that total consumer and producer surplus, which the consumer surplus is this area of the triangle. So this is a total consumer surplus above and beyond the price they had to pay. And this area of this pink triangle right here is the producer surplus. And this is the benefits to the producer above beyond what they were willing to accept as prices. And so the total consumer surplus of this area of the triangle is just 1/2 times the base times height, and that leaves you with a triangle of or area of $20. The producer surplus is the area of this triangle, the 6 minus 1 times 8, and 1/2 of that. And that's $20 for that triangle. Now, in terms of the total surplus from this market outcome of equilibrium price and quantity here, is this area of both consumer and producer surplus. So this is the total welfare surplus from a socially efficient outcome in the market. On the previous slide, we showed consumer and producer surplus, it leads to a socially efficient outcome that maximizes the surplus for both the producers and consumers. And the thought is, if you deviate from that socially efficient outcome in any way, you're going to reduce the welfare either to the consumers or producers, or possibly both, in the market. And this reduction in welfare is considered deadweight loss. So this is when there's a loss of one group that is not offset by a gain to another group in the market. And how large this deadweight loss is a function of something called the elasticity, price elasticity of demand and price elasticity of supply. We'll get into a bit more of what that means in a second. Okay, so let's work through the example of deadweight loss here. All right, so at equilibrium, we have QE as a quantity and PE. And say the government decides that they're going to set a ceiling on the price. And so they're going to set a ceiling here of PR. So for instance, in the 1970s, the government put a maximum price on gas. And this led to long lines, if you've ever seen those videos. And why did it lead to those long lines? Well, with this lower price than the equilibrium, consumers would like to have this amount of gas, but the producers are only producing this, and that leads a shortage of this amount. Well, what does this also mean in terms of consumer and producer surplus? So the consumer surplus originally was this whole blue area that included A and D. But now, with this reduced price, it goes from A to D, A and D to A and B, but we do lose D here. And so the change in consumer surplus, that's what this delta means, the change in consumer surplus is how much this area B is minus this D. Okay, on the producer side, the original producer surplus was this pink area that included C, B, and E. And now the producer, the change in their surplus, they've lost B, so that's why that's a negative here, and they've lost E, and they're only left with C. Well, what is the deadweight loss then? Well, it is this D and E, because if you look at the change in consumer surplus versus a change in producer surplus, consumers got to add B here, producers lost that B, so that just offsets. But both, or together, they lost D and E. And so that's the change in producer surplus here, the loss of D and E, and that's your deadweight loss. To think about this in layman terms, anytime you change either the price and quantity from an equilibrium efficient outcome, people are going to be less happy, or producers are going to be less happy with that outcome, and that's what we consider deadweight loss. A couple slides ago, I mentioned the fact that deadweight loss could be affected by the elasticity of demand and supply. Let's give an example of elasticity of demand. So what is price elasticity of demand? That's the percent change in the quantity over the percent change in price. So as prices change, quantity will change. And the question is, will the percent change in quantity be greater than the percent change of price? So if the percent change in quantity is greater than the percent change of price, we consider that to be elastic. In essence, what that means is with that change in price, the quantity changed more. If the demand price elasticity of demand is inelastic, it's suggesting when that price change, the percent change in quantity changed less than the percent change in price, and that's considered inelastic. So in this case, when price went up, for example, quantity didn't change much in terms of consumption. The last one is unit elasticity, which basically means that the change in quantity or percent change in quantity and percent change in price are the same. So it's not really changing that ratio. All right, and then that last slide we showed elasticity with some simple math. Here we're going to show it graphically. And so we're going to show examples of both being elastic and inelastic demand curve. We're not going to show unitary elastic because these are the two most likely cases of demand. Again, it's just a percent change in quantity over percent change in price. In this particular case, the price goes from $9.50 to $10.50, and that causes the quantity consumed from going from point B to point A, and that leads to a large change in quantity. And so the percent change in quantity is larger than the percent change in price, and that's considered elastic. And as you can notice here, that leads to a flat demand curve. So you could think about products like if we only taxed Coke but not Pepsi, it's likely lots of people would switch away from Coke and consume more Pepsi. So Coke would have large consequences from that tax, and their consumption would change quite a bit. So an inelastic demand curve is reflected here. And as you notice here, a price changes from 50 cents to $1.50. The amount consumed goes from point B to point A, which is from 101 units to 99 units. So the percent change in quantity here is relatively small to the percent change in price. And so this is considered inelastic. And so you can see it has a very high slope. And this curve, or the demand curve, and so you can think of products like gasoline. Even when the price goes up, lots of people still just have to drive, and so the consumption patterns don't change that much when prices change in those products. So this is elastic and inelastic demand curves. So why does elasticity matter? Remember in the last slide, we showed an elastic demand curve, which is flatter, and an inelastic demand curve, which has a higher slope. And let's use an example where there's a tax placed on this good. And originally they have an equilibrium quantity of 10, and it looks like it has an equilibrium price of 20 here. And this new tax goes into place, and what that causes is the supply curve to shift left, so it goes from here to this curve, and a new equilibrium price and quantity will go from this 10 and 20 to this new amount, which looks like it's about 5 and around 23 in terms of price. And the deadweight loss will be this triangle right here. And it's relatively large because it has an elastic demand curve. And when you have an elastic demand curve, it means there's been a large change in behavior. And again, we want to try to minimize how we're changing behavior in the market when we intervene. And then in this particular case, we're really changing the market quite a bit as consumption is cut, looks like at about a half. So let's go to the inelastic situation. So again, there's this tax. It causes the supply curve to go to the left here. And it leads to the equilibrium quantity going from 10 to 20 to a new equilibrium quantity of, looks like it only changed to 9 on the quantity, and maybe to, I don't know, around $23, $24, $25, something like that. And in this particular case, because behavior has not changed much, we have not affected the consumer and producer surplus as much, and it leads to a lower deadweight loss. So the lesson from this in terms of policy is that economists argue that you should tax things that minimizes the change in behavior. And in this case, when you have inelastic demand curves, it's going to lead to less change in behavior in terms of consumption patterns, and therefore less deadweight loss and less efficiency loss from the intervention from the government.